Thanks, Emery. Appreciate it. All right, now it is. All right, shoot. Doggone it. Well, what the hell? So the point I was trying to make was 98% of the time, if a coil fails, it's going to fail open, which is to say it's going to end up having OL, infinite resistance. So I don't really care about the resistance because I know if it's OL, it's bad. Does that make sense?
Yes.
Yeah. A lot of people don't know how to do that test, and it's a freaking shame because, you know, they're replacing all this stuff for no reason because they don't know how to test it, right? I mean, at one point I called up the Ford dealer and I said, do you have this Ford coil tester that it describes in the service manual? And they're like, hell no, we don't have that. I was like, oh, well, okay, what do I do? So you can test all kinds of coils like this, you know, shift solenoids, all kinds of stuff like this. So Rudy's correct in the sense that it would be better if you had the exact specification, but even if you don't, if you're just doing quick testing,
yeah,
all you have to do is look for an OL. I mean, let me ask you a question. If I have an open in my circuit, super high resistance, how much current flow will I have?
Zero.
Zero, which means nothing's going to work, right? Make sense? Make sense? Yeah?
Oh yeah, we're done.
Okay. Okay, so you're going to see coils all over the car, like analog brake wheel speed sensors. Coils like this. I mean, it's easy enough to disconnect the connector, get in there with an ohm meter, and see what kind of resistance you're getting. So these are basic electromagnetic devices. That's a coil, and there's a solenoid. Notice they both test the same way. Now let me ask you a question. Just because the coil is good, does that mean that that rod is free to move?
No.
No.
Yeah.
No. There's two different parts, right?
Okay.
So, but I know that if the coil's bad, the rod ain't gonna move, right?
Right.
Yeah. So it's a quick and dirty test. It's not bulletproof because, as Rudy pointed out last time, if you've got a fuel injector that is stuck open, there's a good probability that the coil is still good, but the rod is just stuck. Now, let me ask you a question. What's going to get that rod stuck?
Dirt, grime, carbon.
How about all the alcohol and the gasoline sucking in water and killing it? Yeah, because that's a 94, right?
Mm-hmm.
It wasn't. Oh, jeez.
That happens quite a lot, huh?
All right. Freaking Rudy. All right.
Does that happen a lot?
Yeah, which is why you don't see many old cars on the road, because basically all that alcohol just destroys their fuel systems. Yeah. Because, I mean, the pump's not made for it. The injectors aren't made for it. It just basically goes through the whole system and just corrodes it to death, basically. All right, so I got a coil and I got a solenoid. Let me try this. Let me try this. I'm going to have a coil like this, but let me do this. I'm going to give you a drawing here, which is not technically accurate, but it is good for illustrating a point.
It's relay.
Yep. Because we know that if I put a solenoid here with a steel rod in it, that steel rod is going to move when I pass current through the coil. Okay. Goes like that. So when I pass B plus here, got a ground right here. What this little rod thing's going to do is it's going to come down here and close this switch. So basically, I can use a little bit of current to control this switch. So it's like instead of having to reach all the way over to the light switch, I can do it with a solenoid and a switch. And Chuck is absolutely correct, because that thing right there is called a relay. And back in the olden days, this is how we used to control large currents. Because the definition, a relay is an...
That's also how you do multiple amplifiers.
Sure. Anything that's got a lot of current. A relay is an electromagnetic device that, I suppose that should be which, uses a small current to control a larger one. Now, I don't know, this could be 100 amps. Could be 200 amps as far as that goes. This could be, I don't know, half an amp. Could be less, could be way less. Milliamps. See, because all we have to do is we have to construct this device and pump enough current through it to where it will activate and close the switch. Ah, let's see, good. Hooray! Who yet? Oh. Galaxy S10, who's that?
Me.
Oh. Are you getting...
Jim.
Yeah, but are you getting dropped? Because I already have you on here. I'll call you J-Not 2. All right, 489-826. Who are you? 489. Oh. 489-826. Who are you? Oh, that's Daryl. How are you, dude?
Hey, how you doing? Oh, dang. Okay, how you doing?
Great. Great to have you, man.
That's good. I'm sorry I'm late. I'm still in my work clothes. I haven't did nothing yet. I'm all the way late with everything.
Well, that's the best thing.
At least you made it.
I'm in my work clothes too. Or so you think.
Uh-oh. Oh, let me mute because I got the baby in here yelling.
Well, that's good. There we go.
Can y'all hear me? I'm on mute or unmute?
You're unmuted.
Okay, let me mute because the baby kind of yelling.
Okay, when you mute, all you have to do if you want to say something is hit the space bar and it'll unmute you temporarily. Okay, so we know from our studies that the size of the conductor has to be proportional to the amount of current that flows through it, right?
Right.
True.
So if I had something like a starter motor, if I wanted to use a switch to turn that starter motor, I would require a switch that, you know, can carry 200 amps. You know how big a switch that can carry 200 amps is? It's like ka-chonk, ka-chonk. Now, is that what we want to do when we're turning the key? No.
Nope.
No. Okay, so then how do we control that big old starter motor drawing 200 amps, 250 amps, whatever? How do we control that big old 250 amp starter motor with a number 16 wire?
Relay.
Yeah, we use relay.
With the starter relay.
Absolutely. And the same.
Or they call it the starter solenoid.
No, starter solenoid and starter relay are two different things. The starter solenoid pushes the pinion gear out to make contact with the ring gear. The starter relay is what actually makes
it. Can also have the relay built in it, though.
Yes. Now, if you're talking about like General Motors, they've got the starter relay and the starter solenoid in the same mechanism. But if you look at a Ford, you've got the starter relay on the fender well and the starter solenoid is on the starter. So yeah, I honor that distinction. Okay, so a relay is an electromagnetic device that uses a small current to control a larger one. Now, we already discussed the fact that we don't want to be dumping a whole bunch of current through our computers, because our computers, we want to keep them cool. And the more current you have, the more heat you're going to create. So if we're going to control a relay, we're going to do it with a computer because, say, for instance, you know, the fuel pump's probably 30 amps. Let's see. The starter is probably 250 amps, depending on the car. Fuel pump is probably 30 amps. AC is probably 30 amps. Lights, depending on the vehicle, is probably 20 amps. Now, we don't want that kind of current flowing through our computers, but we do want to be able to control this stuff with the computer. So what do? We use relays. And relays are those ice cube looking things. Mm-hmm. Not Ice Cube, the rapper, the other Ice Cube. Look like that, big squares. How many pins come out of a relay?
3, 4.
Depends, right?
4 to 5, 6, depends.
Yep.
The minimum is 4. The max I've ever seen is 6.
Yeah. Nissans and Mercedes comes out with 6. Did I send you that big old PowerPoint on relays? Rudy, have you been watching the training through Diagnostic Network?
I have.
Really?
No, I haven't been able to.
Yeah.
Really? What'd you watch?
How electromagnetic systems work.
How what? I'm sorry?
No, not electromagnetic. The electrified systems, electrified cars.
Yeah, see, Rudy, now she knows more than you. What's up? She's going to take your crown, buddy. Good for you. How'd you like it?
Interesting.
How'd you like it?
It was cool.
Yeah.
Yeah. I fell asleep, though, at the end.
Yeah. Welcome to my world. Okay, so since we're only using milliamps here, we can use a much smaller switch, which is useful because, you know, big switches are expensive. Plus, you know, little switches you can do with your pinky, your fingernail. Big switches, you have to colunk. You know, 200 amps is the size of the switch that turns off the power to your house. It's big. Okay, so let me show you, and I'll show you. That like that. All right, so here we have the starter motor over here. It's a starter circuit. Starter circuit. All right, so there's a big old starter motor. It wants 250 amps. Well, it's got to get it from somewhere. So it comes over here. Go like that. And it's got this little switchy thing right there. And it's got the other switchy thing right there. And this goes straight to B+. So can you see if I close this switch that motor is going to start to turn?
Mm-hmm. Yes.
Okay. Now, up here, I've got the coil. And I'm going to stick this side to ground. And then I'm going to have to come over here. I've got B plus going like this. But then I'm going to go like that. Call that the starter switch. Where's the starter switch located?
In the where the key is, right?
Yeah,
Ignition.
yeah, it's in the ignition switch. Good. You know, because you go off, accessory, ignition, start, right? And that's why it's got spring loaded. So
Depends on the car.
what? What depends on the car?
The Dodge, for example, accessory is back,
Right.
then off,
I
then ignition, then start.
All right. Now, what about this? We got another switch in there. And this thing right here is going to be the clutch switch or
Manuals only.
park neutral safety switch. Yep. This one's for manual trans, that one's for automatics. I'm gonna go like that. I'm gonna go like this. Say PCM. What's PCM?
Power control module.
Powertrain control module, yep. Okay, so the clutch switch. Clutch switch is the thing that won't let the starter turn unless your foot's all the way down on the clutch.
Mm-hmm.
What's the purpose of that?
So that it can disengage or engage the clutch pedal.
The clutch. Yeah.
Gears.
No, it's so it doesn't leap forward when you turn the starter on.
Oh, okay.
Yeah. Same thing with a park neutral safety switch. It makes sure that the starter won't turn unless the vehicle's in park or neutral. That way it won't leap forward as soon as the engine starts, or just through the power of the starter motor.
Okay.
Now, of course, this switch on most modern vehicles is going to be incorporated into the PCM, since that's going to be coming out of the transmission control module. But the PCM, if you have a theft deterrent or something like that, the PCM has to close that switch in order for the starter circuit to get the starter motor to turn. Now, so you can see I got 3 switches in series. 1, 2, 3, coming right after each other. And all 3 of those switches have to be closed or no starter turning.
Yeah.
Okay. What I'm going to do is I'm going to come in here like this and kind of tear the relay into 2 pieces. In fact, I can tear the circuits into 2 pieces too, because this is the control side of the circuit and this is the power side of the circuit. Now, the power side of the circuit is high amps. The control side of the circuit is low amps. Because I don't need much more than half an amp to control all of this. Yeah?
Mm-hmm.
Okay. But you can see if I'm only running half an amp that I'm going to be kind of vulnerable to resistance issues. So I want to make sure our connections are in good shape. Okay, so we've got, every relay has 2 parts. It has the control side, it has the power side. The power side is what does the big amperage. The control side is what does the little amperage that controls the big amperage side. That make sense?
Wait, could you say the last part of that sentence again?
We got the
control
power side, which is high amps.
right?
We got the control side, which is low amps.
Okay.
But we can see that if we have low amperage, we're going to be kind of sensitive to resistance issues.
Yeah.
So we're going to need to be aware of that. Make sure our connections are in good shape. There's a lot of relays like that. In fact, pretty much every relay is like that. You know, like your daytime running lights, for instance. The computer is going to connect B plus to this circuit, which is going to turn on your headlights. That's how it works. Based on a photo sensor in your dashboard. Lots of relays work like that. In fact, okay, put it this way. While we're talking about the guy in the Camaro, they have in modern vehicles, at least in the old Fords, they used to have this thing called the anti-rollover switch, because what they found out was happening was when they had electric fuel pumps, what was happening was when the car flipped upside down, the guy would be sitting there in his car, crushed in his car, so he couldn't get out, and the electric fuel pump would still be turning because it was controlled by the ignition switch. But when it came to computer controlled vehicles, there's a couple of things that have to be satisfied before it's going to turn on the fuel pump. So you got this?
Yeah.
Yeah?
Yeah.
Okay.
Yeah.
All right. Give me a bump pop.
Ice cream man.
Yeah, I know. Fuel pump control. Okay. Number one. PCM turns on fuel pump for 2 seconds. For what?
To be pressurized.
To pressurize the system. Yeah, good. So the PCM turns on the fuel pump for 2 seconds. There's a fuel pump relay. All it has to do is energize that little bitty coil, and the fuel pump will start to turn. So it'll pressurize the system, which is going to make the engine start more quickly, which is kind of a priority for a lot of people. Okay, then the PCM shuts off the fuel pump, and it will not turn it back on again. PCM will only re-energize. Man. Jeez. RPM. RPM signal? I was going to say above 600, but I don't think that's right. It probably depends on the car. But PCM will only re-energize the fuel pump if it sees the RPM signal. Now, who wants to be student of the year? How does the PCM know that the engine is turning? Not Rudy.
Crank sensor.
Good. Crank sensor. That's it. From CKP, which is crankshaft position sensor. Yep. Good. So what that's there to accomplish is, if this car flips over and the engine stops turning, the PCM is going to shut off the fuel pump, thus keeping people from being bathed in gasoline. It's horrible.
Yes.
So PCM will only re-energize fuel pump if it sees RPM signal. So what the PCM is controlling the fuel pump relay, and it's using very small currents to do that, which is the only way we can keep that computer cool. Because it's not like the computer has a fan or anything. Now, we used to have a bunch of problems with the computers because they were getting too hot, but we kept getting smarter and smarter about how we were going to control these things. So let's look at this relay. Number one, I got this coil. And number two, I got a switch. Now, electronic components are always shown in their de-energized state, which means, is that switch open or closed?
Okay.
Good. Yeah, so this is a normally open switch. Oh, incidentally, if you want to get a pizza with a lot of toppings on it, that's pretty homemade and decent, the Trilli's on Central from Home Depot, across Arrow from Home Depot, had like 5 pounds of meat on it. I bought it on Sunday and I'm not even finished with it yet. I've been working, I haven't eaten anything else. Starting to get a little old, but yeah, it's amazing. I've never seen a pizza with toppings like this before. They're not cheap, but it puts it out. My friend has this concept called the meat to bread ratio. It's like how we judge like burgers and stuff like that. The meat to bread ratio needs to be extraordinarily high, right? When you get a burger that's mostly bread, you're like, oh no, it's unacceptable. No. Okay, so anyway, the point I was trying to make was Petrilli's. I noticed the pot shop next door was doing rave business, and you didn't even have to wear a mask. Surprise. Anyways, this is a coil right here. So how can we test that to make sure the coil's good?
Ohmmeter.
Yeah, ohmmeter. Good. Now, how can we test this to see if the switch is good?
You have to put 12 volts to it.
Yeah, see, that's the thing. And even that is not foolproof, because if this thing is supposed to pass 30 amps, you have to realize that your ohm meter on your DVOM is only putting out like 1.5 volts. It's putting out milliamps. And a lot of times these contacts can be good enough to pass milliamps, but they won't pass 30 or 20. So,
But can't you do it with a clamp amp meter?
sure, yeah, absolutely. And that way you wouldn't have to pull it out. Sure. But see, it's kind of complicated now because now we got the BCM doing all this stuff, and it's hard to figure out, you know, well, should there be power here or not? What's a BCM? BCM? Hey,
Screen control module?
body control module, yeah?
Oh, I thought you said P. Okay.
No. Body control module. So it controls all the doors and the windows and the horn and the dash? No,
Lights? Does it do the lights?
air conditioning, the lights, radio, yeah, all that stuff. Yep. So it's hard to know, you know, when voltage is supposed to be there, stuff like that, because, you know, it's got the same issues where, like, it has to have certain conditions have to be met. Like, for instance, you can't open the door on my Corvette as long as the engine's running, unless you press the little unlock button, and it won't open the hatch unless the parking brake is up. I'm learning all these things. So yeah, I can use an ohm meter on this. Just do a quick and dirty. Is it, you know, open loop? I mean, out of limits or not? Because, like I said, the number one way these go bad is the freaking coil opens up because of too much heat. Problem with this thing is, you know, we don't know if the contacts will carry the rated current flow. So a lot of times you'll get fooled on this, like with Power Pros and stuff like that. A lot of times you'll get fooled with it because you'll say, well, I mean, it opens and closes. Yeah, but it won't carry 20 amps. So the testing of relays is pretty imperfect. What most people do is they look in the relay box or the fuse box, and if they see another one with the exact same part number, they just swap it in there and see if it fixes it. It's an ugly
I
fix.
had that happen to me.
Yeah, it's an ugly fix, but people do it all the time, so must be useful. Yeah. All right. Now, is every relay normally open? No. Some are normally closed. Hey, Rudy, do you remember the pinout on a relay?
Yes.
This is 30 and that's 87, right?
87 is the normally open. 87A is the normally closed.
Then
30 is your common. 85 and 86
Oh,
are your coil.
right, my bad. That's 85 and 86.
Oh.
Bad teacher. Yep,
God, it's sad I still remember that.
that's funny how it works, man. Yeah, it's funny how it works. All right, you got that?
Yep.
Oh, shoot, sorry about that. Should have told me, man. There you go.
That would be a single pull, single throw relay.
Yeah, which you don't see too many of, but they do exist.
You can see a lot of them if that's what you need to use it for.
Right.
Like in your car audio, that's the best relay to use.
Right. Okay, well, what Rudy's saying is, how do you
Ah, God, the rats. Sorry.
draw it like this? And then it goes to that. And then it could go to this. And then over here, you've got like that. So that's 85 and 86. This is 30. Which one's 87? Which one's 87A? Ha ha. Do you remember? Rudy.
I will stay quiet.
Oh, here it comes.
87A is the normally closed. 87A is the normally open.
Thank you, my love. There you go. Just in case you see a relay and it's got numbers on the bottom. Sometimes they'll have a little diagram on the side, which is helpful. But I hope you got your glasses if you're trying to look for these numbers, because they're not.
They're also on the top of the relay.
Oh, when? I can count the number of
I
times
will bring you-
and I've seen that. I wish they were, put it that way. All right, so that's relays.
The one that's rare is the one that's a black relay with a white schematic with it outlined in black.
Right, yeah, very useful. Wish we had more of them. Okay, so that's relays. Questions, comments, thoughts on relays? Let me go to, well, calling electude, right? Hey, Jimmy, did I send you a invitation for electude?
I sent you a message. It says I'm not allowed because I have an unknown email.
I'm so sorry. I'll do it right after class. I'm so sorry.
Okay.
About that. All right. The next thing goes like this. I'm so sorry, bud. That way. And then this goes this way. But in order to understand this, we need to understand more about electromagnetism.
That's a step-up transformer.
That right there is a transformer. More than meets the eye.
Step up or step down, depending on which way the current flows.
Yeah, but I don't want to get that far yet because we got to understand some more stuff. Transformer, for the most part, 98% of them is there to change voltages. Why is that useful? Well, because for instance, on a spark plug gap, you're not going to be able to jump across that with 12 volts. You need 12,000 volts. Okay, well, where are you going to get 12,000 volts? You're going to get it from a transformer. Where else are you going to see transformer? In my beautiful amp? Yeah.
Yep.
Yep. All right, you got this?
Mhm.
Oh, wait, you sold the vet with the killer stereo system, huh?
Yes.
We should have pulled that sub box and put it in the red one.
Well, it's a little late.
What's the difference between a transformer and an inverter?
Inverter changes DC to AC
Okay.
or AC to DC.
DC to AC.
Mhm.
It's the same thing going the opposite direction. Well, for instance, most of your transformers, like
Ignition coil.
battery chargers, are going to go from 120 volts to 12 volts. Most of your inverters, at least as far as cars go, are going to go 12 volts to 120 volts. Now, what Rudy's saying is the way most inverters are used in cars, they go from 12 volts DC to 120 volts AC.
Mm-hmm.
Just like this goes from 120 volts AC to 12 volts DC.
I gotcha.
But that's not a strict transformer. That's a battery charger, really. So I'm going to go ahead and erase that because I'm not happy with it. Okay, but here's what I am happy with. We talked about electromagnetism. The three things that determine how strong a magnetic field is created by the flow of current are 1, the amount of current, 2, how close all the parts are, and 3, the number of coils. Well, passing a magnetic field across a conductor creates voltage or current or current, depending on the resistance.
Maybe.
For instance, if you have one of these things right here, which is an ABS trigger wheel, and these are magnetized teeth, and you put a coil right here, this coil is going to output alternating current, and the frequency of that alternating current is going to be proportional to how fast this thing is turning. This is the same way, well, so that's ABS, that's camshaft position sensor.
About a crank sensor.
Vehicle speed sensor, that's crankshaft position sensor, that's the input shaft speed sensor on your trans. That's your output speed sensor that's going to check for slip.
Oh, a lot of them.
There's a billion of these. Yeah, for instance, electronic ignition. So this is a big deal. This is big medicine.
No, okay.
Passing a magnetic field across a conductor creates voltage or current. Well, just like we did before, we're going to say how much. Well, number 1 is going to be determined by the strength of the magnetic field. Because remember, all your magnetic fields have polarity, right? And what's inside your conductor is all electrons, yeah? So what happens is as we pass a magnet across this conductor, When the charges are opposite, it pushes the electrons away. And when the charges are similar, it draws the electrons this way. And as you can see the electrons are going in a wire because they're being pushed away and then they're being sucked back, pushed away and then they're being sucked back. And if you were to chart the voltage, it would look like this. It would go positive and then it would go negative. All that means is positive is one direction, negative is the other. That's all it means. So the stronger the magnetic field, the more of a push you're going to get on those electrons. The more you're going to push and the harder you're going to push them. So the number one thing that determines how much voltage and current is created is the strength of the magnetic field. Now, number two is, of course, proximity. Because, of course, this is going to be more intense the closer you get. You know, you can't get too close because when everything gets hot, it expands. You got to make sure it doesn't hit each other, but that's pretty much the limit. Number three is the number of windings. So as you can see, two of these are exactly the same. Whether we're generating magnetic fields or whether we're generating voltage and current. Number four is the only one that's kind of tricky. Number four is the speed of the cutting action. And the reason it's called cutting, let's do that, is because you are cutting lines of force, magnetic lines of force, right? Because like you saw my old magnet, when I'm spinning that around, the magnetic fields are spinning with it, yeah?
Yeah.
Okay. So the same thing happens here, man. It's got magnetic properties, just like your crankshaft position sensor, your trigger wheel on that. Chuck's absolutely correct. And when that spins, what it's going to do is it's going to first push all the electrons this way, and then it's going to push all the electrons that way. All positive and negative means is it's going one direction this way and the other direction that way. That's all it means. Not complicated. Okay, so you got that?
Can you move the page up a little bit? There it goes.
Yeah. Oh, really? I got like an inch of space on mine. Okay, good. Thanks for letting me know, guys.
Also depends on their screen, real Cliff.
Does it? Okay. All right. All right, you ready?
Uh-huh.
Ooh, coronavirus.
Nope. Smoker's cough.
Uh-huh. All right, you ready? Okay. All right, so faster speed equals more voltage and current. Which is why when we're running an alternator, remember, this is the crank pulley. This is the alternator pulley. I've taught you this before, but we'll see how it works. That's 10 inches in circumference. This is 2 inches in circumference. So if this is going 3,000 RPM, how fast is that turning?
15.
2,500.
A lot.
What's the ratio between 10 and 2?
5.
5.
1.
Good, good. So is this going to be turning faster or slower?
Faster.
Faster, yeah. So the correct answer here is
15,000.
5,000.
15,000 RPM. And the reason we want it to spin so fast is because it's going to create a lot more voltage and current when we do it that way. Yeah? That's why when you're jump starting a car, you're always supposed to raise up the RPM because it's going to make the alternator more efficient.
And you make sure you turn everything off in your car.
Yeah, that's true. Sure. Okay. So if I was to look at it this way, this would be volts. That's 0. And this right here is time. This, shoot, did that wrong color, sorry. This measurement from here to there is called amplitude. All that says is how big the signal is. Unfortunately, I left my demonstration stuff at work. Or you could go like this.
Hey, Rowcliffe, do they make a meter that you can check alternators with?
What do you mean? Yeah, I use voltmeter. What are you talking about?
Like checking the amplitude of the sine wave,
No, not
the
usually.
alternator.
Because remember, the regulator is internal, right? I mean, you could
Oh,
probably
okay.
take the alternator apart and do it that way, but that would be a lot of work. Okay.
No, I just thought maybe there's a device you could set on it and it would pick up the magnetic waves to show you the amplitude of.
No, not easily. Okay, so
Okay.
I do
Because
got
I
a
know they have
question.
one for
I do got a question on that.
RPM.
yeah,
Can you see that?
no, yeah,
I use that to run across the battery when I rev the alternator up.
right,
And if the meter pegs one direction or another, I know there's current flowing.
sure, yeah, absolutely.
That's an old school way, but tells me something.
Isn't that an inductive ammeter? Yes, it is.
Yes.
Yeah, it's just the old school.
It's an old school inductive amp meter, but it's an amp meter.
Yeah, one of the problems you're gonna. Okay, so Chuck, that has a 0 to 75 reading on it. Can you stick it back up in the camera?
No,
Okay.
600.
Yeah, but it says 0 to 75 on the bottom. Is that switchable?
No, the back end, you just lay it on the wire.
Yeah, because one of the problems of trying to test alternator output is that, you know, it could usually only be like 20 or 30 amps. So it could only run, it should only move that needle a little.
Right.
Yeah, okay, all right,
That's just, you know,
sure.
I don't know if it helps Rudy or not.
Yeah.
Or answer his question.
Okay, so look at this one. Well, you know, actually I could do this. I could fill in the area under the curve, which is the charging. And you can see also that I have this little rascal over here.
Alternator's dying.
Yeah, you can see that this is very low amplitude, right? Now, this right there is frequency. Based on how often does this happen per second, right?
In a second.
Yeah, hertz, cycles per second. Cycle defined as
For example,
starting over.
a 60 hertz frequency will change direction 60 times in 1 second.
That's correct. And a lot of times you'll see that called hertz. and abbreviated HZ. And you can see that this is happening in a much smaller amount of time, so that means it's going to be a much higher frequency. This is a much lower frequency because it takes a lot longer to happen. This is the sine wave. And this is most commonly associated with alternating current. Yep. Or as most people call it, AC. Okay, so there's two parts of the electromagnetic coin, right? There's creating magnetic fields with current, and there's creating current with magnetic fields. And we have to understand the second one in order to understand how transformers work. And we're going to go into transformers now, and that's almost as far as we're going to go, because transformers is what we need in order to understand how ignition systems work. So that is what we shall be doing when we return from break, which is going to be just a moment. Questions, comments, thoughts on this?
Yeah,
What?
the ratio between the crank and the pulley. What's the mathematical formula we have to do?
Well, the circumference, which is to say the measurement around this crankshaft, is 10 inches.
Right.
The measurement around this pulley is 2 inches, which means every time this turns once, how many times does this turn?
The same thing.
Nope.
No, no. It's turning twice as fast. It's turning 5 times as fast.
It's turning 5 times as fast. Because look, let's say
Oh,
that, let's say that there's a ladybug on this crank pulley. By the time this crank pulley has turned one turn, how far has the ladybug moved? 10 inches, right?
Yeah.
Which is 5 turns of this thing. Yeah.
You put it that way.
So yeah, it's all about ladybugs, right? So the ratio is 5 to 1 between those two. Yep.
So you're gonna divide two into 10 to get the 5 ratio, or?
Yeah.
That's my question.
Yeah. 10 over 2 is 5. Yeah.
Yeah.
Okay, so we divide them.
My question is, I can't really see the hertz. What's on top of second?
Cycles per second.
Cycles per second.
Oh, that's what that says.
Okay, that's where I'm lost. Sorry about that.
Yeah, you guys better hurry up and get your complaints in because you're running out of time. There. See? Now, you happy?
I got it.
There we go. All right. Yeah, I just had a student that just joined the union. He's only 17, and they took him anyway.
Oh.
Well.
Yeah. When was the last time you heard of 17 that actually wanted to get a job? So.
How much does he get? How much is he making, Dave?
I don't know, but starting in the union is like $15, isn't it? With full bennies and vacation and sick leave and.
Oh wow.
That's cool.
All that schooling. So okay. Well, folks, we're at break time, so why don't we hit it back at 7:45?
Yeah.
Okay. Sound good.
Maybe my good friend Anna Maria will remind me to start the recording again. Zoom recording. There we go. Yep. Welcome back, everybody. Thanks for being back on time. And I just want to point out that we are talking about creating current with magnets. And that leads directly to a discussion of alternating current, because after all, we know that alternating current is created by rotating magnets. Now, why do we rotate them? Because, going like this, a reciprocating motion, is not that great. If we just put it on a circle, we can keep the magnets coming and going and coming and going and coming and going all the time. So, you got this? Okay. So let's look at this and see what it beholds. Now, this is a coil, just a coil. And I'm going to pass current through this coil, which is going to create, which is going to create a magnetic field, right?
Yes.
Right?
Mm-hmm.
Yes, it is. Okay, so that's going to create a magnetic field. Now, this part doesn't really matter. It's an iron core. That's just a symbol for an iron core. And the reason it's there is to make this more efficient. And then there's going to be another coil right there. Close in proximity, yes. You'll notice this has a lot more windings. Yeah?
Mm-hmm.
Now, my question is, current flowing through this coil creates a magnetic field. Well, what do you think this magnetic field creates in this coil?
Attraction.
What do magnetic lines of force create in a conductor? Passing a magnetic field across a conductor creates voltage and current.
Oh,
Yeah?
okay.
So that's what we're doing. Because we're going to pass current here. And you can't have any current without voltage, right? Pass current here. And you get current here. You say, well, who cares? Well, here's the important part. This is the part that matters. I've got 12 volts over here, but now I'm splitting up all of this magnetic field among a whole bunch more windings, like 1,000 times more windings. So now instead of getting 12 volts over here, now I get 12,000 volts or 12 kV. What does K mean?
1,000.
1,000, yeah. Now, voltage is always going to be proportional to the number of windings. So this is always going to be the low voltage, this is going to be the high voltage. And whether, you know, if you go 120 volts AC across a transformer to this, like in a computer power supply, you're going to get 12 volts output. That's called a step down transformer because the voltage is going down.
Right.
This is called a step up transformer because the voltage is going up. This is what we use in cars. This is what we use in, for instance, computer power supplies. And remember, the whole purpose of transformers is to change the voltage. Why do we want to change the voltage? Well, because we don't really want, you know, 120 volts running around our circuits. Besides, in a computer power supply, remember, everything's running off of 5 volts and 12 volts. We don't want 120 volts running around. It means we'd have to space the parts out too far because higher voltages will jump, just like higher pressures will leak. Okay, so this is a step-up transformer. This is a step-down transformer. We don't see too many transformers in cars, except in the ignition system, in which they're the very heart of the ignition system. But this is transformers. You got this? Can I go to the next page? Okay.
Yes.
Yes.
Okay, so let's say I've got, shoot, wish I hadn't done that. 12 volts at 10 amps. And then I'm going to come over here like this. I'm going to get 12,000 volts at what?
50.
Well,
Okay.
here's the
Oh, I
thing.
see.
This times this has to equal this times that. So that's going to be 0.01 amp, right?
Oh.
If you multiply this times this, you get that.
Sorry.
That's 120
0.01.
watts, right? Now, is this transformer going to get hot while we use it?
Yes.
Yes.
Yeah, so you're not actually going to get all of this output, but you'll get 90% of it. Doesn't matter, you're stuck with whatever you get. Okay, and you can see that if we kick this up to 20 amps, that'll be 0.02 instead. Is that right? 120 watts. Jim, what's 12,000 divided by 120?
1,200.
No. If I had a calculator, I would know. It doesn't really matter. The important thing is we need the high voltage. And why do we need the high voltage?
It's 100.
100 amps? I'm being stupid now. This divided by 120 is, yeah, 100 amps. Sorry.
That was my next answer.
Gotta learn how to count, quack. Gotta learn how to count. All right, so why do we need the high voltage? We need the high voltage to jump the spark plug gap. Yeah, I don't know where those numbers came from, but I could, from looking for it, from looking at it, I could tell it was wrong. High voltages are necessary to jump the spark plug gap. Sorry. There we go. Now, you got the center electrode of the spark plug, you got the side electrode of the spark plug. There's nothing connecting them. You're going to have to jump air, and you're going to have to jump very turbulent hot air, which has a whole lot of resistance to it. So in order to overcome resistance, we need really high voltage. And that's what we're doing with the transformer in the ignition system, is we are kicking the voltage so high that it will actually jump the spark plug gap. Now, old ignition coils from me and Chuck's day would probably put out 12,000 volts. Modern ones will put out like 40 or 60, sometimes 80. And that's to give it greater durability, because remember, modern spark plugs will last 100,000 miles because they've got super, super high voltages, which will blast through pretty much anything, almost. All right. So we need to create high voltages in order to jump the spark plug gap. And the spark plug gap is la ancha, right? Oh, shoot. At least the lights flash. Well, well, well. What up? All right, kid. So, Michelle's back. This gap right here is there. Why do we even have a spark plug gap?
Because heat makes it expand.
No, we have the spark plug gap so that we can get the voltage to jump across it. Because when the voltage jumps across that spark plug gap, it's going to do that in the form of an arc. And that arc is useful for doing what?
Igniting the fuel.
Igniting the air fuel mixture. Good, 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 good. Okay, you ready?
Yeah.
That way. The purpose of the spark plug is to ignite the air fuel mixture. Sorry. Yeah, I tell you what, don't do yourself a favor and don't ask 100 professional mechanics what the spark plug does, because they'll just boo blah boo blah. The purpose of the ignition system, coronavirus, is to fire the spark plug. Well, we've pretty much done all of the electromagnetic devices in the car or truck, which is what, I see, I didn't warn you, but sad to say, you know a lot more than 90% of the professional mechanics out there today. Sad to say, you know, because they won't sit down for an hour lecture. That's why they keep making $15 an hour for 40 years. The purpose of the ignition system is to fire the spark plug. So that's very simple. All the ignition system is doing is firing that spark plug. And all the spark plug is doing is igniting the air-fuel mixture. So it's really simple in that regard. Over here we have that, and then this goes like this. And that goes like that. And then it's got a sweet little nubbin right there. Is that about right? Those are threads. Roscas, yeah? Says R42. What are the threads used for?
To keep it in place?
Yep, good. To tighten it down so we can make a seal as well, right?
Right.
We got to seal that combustion chamber. All right, what are these flats here used for?
What or what?
So you can put the spark plug down into the
For your
right.
socket, yeah?
to tighten it.
That's correct. And what's this number for?
Temperature.
No, well, yeah, that's true. But what is the number? What is the number really for? If we were to say in general, all the numbers that look like that, they're all part numbers, right?
Right.
There you go.
Okay.
Because every engine doesn't use the same spark plug, right?
Right.
Okay. Now inside the spark plug, what you don't see is that this little conductor right here goes all the way through the spark plug to this thing right here, which is called the center electrode. This one right here is called the side electrode. Now, another reason we have those threads is so that we can connect the side electrode electrically to the heads. Now, the heads are grounded, right? The heads are grounded through the block. The block is grounded through the ground strap or the engine mounts
Yes.
to the frame. Yeah, so all of this is grounded. Okay, so the side electrode is grounded. Now we've got spark plug wires or whatever coming into the center electrode. So all this voltage comes down the center of the electrode and it's looking for a path to ground. It badly wants to get back to ground because ground is a lower energy state. So if the lowest resistance path to ground is across this spark plug gap, it's going to jump the spark plug gap. That's going to give us our arc, and that's going to ignite the air-fuel mixture. That's going to give us a power stroke that speeds up the crankshaft, yeah?
Mm-hmm.
Yeah?
Yes.
I mean, it's kind of hard to understand how the system works without understanding the parts. And it's hard to understand the parts without understanding how the system works. So, we just work at it and we'll get there. Okay, now, right here and actually coming in here and, coming out here as well is made of porcelain. Porcelain is an insulator. An insulator is something that does not allow current to flow freely. Hey, we lost Anna Maria, no? Anna Maria, still here?
I'm here, yes.
All right. Okay, so you just went off my little, okay.
Oh, okay.
Okay. Thought I was losing fans. Good. I'm glad. So right here is porcelain. Inside here is porcelain. This thing right there is porcelain. They use porcelain because it's really hard, which makes it impervious to everything except impact. And also it's an insulator. Because look, you've got high voltage coming down this little conductor, and it wants to get to ground. And if it can get to ground before jumping that gap, it'll do it. And that's one of the biggest problems we have with ignition systems, as we'll see in this episode. All right, you got this?
Mm-hmm.
Yes.
Okay. Well, here's what we're going to do. We're going to bring B plus into here. The ground. We're going to go like this. We're going to come in here like this. I'm just going to do it upside down because it doesn't matter. That goes to ground. This is called the coil primary. And it's called the coil primary because that's where, sorry. It's called the coil primary because that's where the energy is going to be first. 12 kV is the coil secondary. And it's called the secondary because that's where the energy is going to be second. Now, if we had a single cylinder engine, we would just run this directly to the spark plug. Yep. Good old R45. Now, Electude will help you on this. A couple other resources will help you on this. I don't have much time, so I got to kind of blow through a bunch of stuff like heat range and stuff like that. But we'll see how much we can get accomplished. We got a couple of minutes left, so. Okay. Does that make sense? Now, what I'm going to do over here is I'm going to actually put a switch to B plus. Now, what do we know about magnetic fields created by the flow of current? We know that the magnetic field builds as the current flows. And when the current stops, what happens to the magnetic field?
It collapses.
It collapses. Yeah, it just goes away. As long as there's current flowing, there will be a magnetic field being created. And as soon as current stops flowing, no more magnetic field. So basically what we're doing with this switch is what's going to happen every time we open that switch? When we close the switch, it'll build up a whole bunch of electrical energy. When we open the switch, it'll fire that spark plug. Why? Because what's happening is this magnetic field over here is building up a field over here. And that's called the process of induction. That means...
That's also how your induction cooktops work, right?
Yep. Something causes...
Except they create heat instead of a secondary magnetic field.
Right, because the molecules are vibrating, right? Causes a change in something else. Without direct physical physical contact. Okay. Here's the moon, and here's the earth. On the earth, where are the tides the highest?
Moon is closer.
Well, not really. Where are the tides the highest, though? The tides are always the highest on the side of the earth where the moon is.
Moon, right?
Because the gravity of the moon sucks all the water to that side of the earth. That's actually what creates the tides. Where are the tides always the lowest? On the opposite side of the earth from where the moon is. Yeah. It's interesting, isn't it?
Mm-hmm.
That's like an inductive relationship. Like when I go to punch you and you move, but I don't hit you. Induction. Something causes a change in something else without direct physical contact. See? Because what happens is, as I close this switch, current builds in this coil, which creates a magnetic field. That induces a field in this coil. So now there's all this energy in both these coils. Well, what happens is, when I open this switch, the primary field collapses here, and it causes this one to collapse too. Now you've got all this energy with nowhere to go. So it runs to the nearest ground, which is across the spark plug gap, hopefully. At least it better be. Better be. That's why you don't lay your spark plug wires on your exhaust manifolds. So the quickest path to ground, the easiest path to, well, I should say the lowest resistance path to ground for all this energy is to jump across the spark plug gap. And that's how we create sparks. Okay, so now there's no energy in the primary, there's no energy in the secondary. What do? I close the switch again. I build up a magnetic field here, which induces a field here. I open up the switch, this field collapses, and I've got another spark at the spark plug. Now, you say...
And it does that thousands of times a second.
Yeah. Well, hundreds anyway, yeah. Depending on how fast you're going. You say, well, that's fine for a single cylinder engine, but we don't usually see single cylinder engines. That's why we need, well, we used to need a distributor, which would distribute this spark to different cylinders. So let me, you got this?
Yep. Modern cars use coil on plug.
Yeah, but it's easier and smarter to teach it this way. Okay. So down here, I've got the battery. And you're going to want to use a full page on this, folks, because this is a big drawing. That's a battery. That's plus, that's minus. So this is going to go straight to ground. This is going to come up here to my ignition switch. And this is going to come over. So I'm going to come here, 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 here. Little rascal like that. You don't have to draw this very hardcore. Just make sure you understand what it is. Like that. Little Santa hat. That, like that. So you know what these are?
Spark plugs.
Spark plugs.
Spark plugs, yeah. So this is a 4-cylinder engine.
Hey, that gap's kind of small.
Yeah, well.
And that one shorted to
1, 2, 3, 4. 4 spark plugs.
What?
Let's see. Cylinder 1 and cylinder 3 are misfiring because
Well, we're all misfiring these days. So, okay, so that's one spark plug for each cylinder, right? Right?
Mhm.
Yes.
Okay.
yeah.
Over here, what I'm going to do is I'm going to have old school. I'm going to have a distributor cap. I had a distributor to show you. That's a distributor cap. Guess why they call it a distributor cap?
Because it distributes.
Because it distributes the
Because it's on
spark
top of the distributor.
and it looks like a
Because it's on top of the distributor, right? Like they call it a cylinder head because it's on top of the cylinder.
Yeah.
They call that a distributor cap. One of these looking things.
coil packs.
No.
Mm-mm.
No.
At the top of the distributor cap.
There we go.
What is the distributor cap?
It's the top
That's
side view.
there. Yep. Isometric. Yep. That's what a distributor cap looks like. You've probably seen a billion of them. Anyway, now you know what that is. They call it a distributor cap. Now, inside the distributor cap, we have a little thing called a
Rotor.
rotor. Yep. And what's that little arrow, circle arrow mean?
Shows its rotation.
Direction of rotation, because it spins. That's why they call it a rotor, is because it rotates. And what the rotor is going to do is it's going to connect this to that. And then as this turns, it's going to connect this to that. And as it turns some more, it's going to turn this to that. And that's how it's going to distribute the spark that the coil makes to each individual plug. So now what I'm going to do is I'm going to, Rudy, if I was to number that distributor cap, how would I number it?
1, 3, 4, 2.
1,
1,
3,
3,
2, 4.
2. And what's that order called?
Firing order.
Firing order.
Firing.
3, 4, 2. That's correct. Good. That's called firing order because the cylinders don't fire in order 1, 2, 3, 4, 5, 6.
Mm-mm.
One of them does, but hardly any of them do.
Why is that?
Because of the way the cylinders and the crankshaft are, it makes better sense to design it so that it fires like on a Chevrolet, it'd be 1, 8, 4, 3, 6, 5, 7, 2.
Okay.
It has to do where the piston is when the spark plug fires, you know?
Have anything to do with vibration?
Sure.
No.
Yes,
No.
it does. Yes, it does. Because it has a lot to do with keeping the crankshaft continuously and evenly spaced in terms of the firing impulses. Because you'll notice like all the radial engines all have odd numbers of cylinders. So you've got to figure out a way to get it so that there's even spaces between all the impulses. Like for instance, on the Harley, it's not like that, which is why the Harley is always going to go, you know? You didn't know that, but I learned that at Citrus College in the High Performance Auto program. Engine design class you should take. Word out to Professor Brown. Okay, so I'm going to take one of these wires and I'm going to put it out right there. Thanks, Professor Brown. I'll give you mad props, Citrus College, High Performance Automotive program. Teaching old dogs new tricks. And number 2 goes over here like this. Hey, Chuck, what are these orange wires?
Oh, those spark plug wires.
That is correct. Thank you. I'm going to come over here, jump that little gapper, and go over there. Those are spark. Can you read that? Plug. Boy, it's really
Barely.
It's glowing hardcore for me. What do you mean barely? Well, get off your iPhone.
The orange doesn't show up good on the camera.
Get off your iPhone 3. It's showing up great on mine.
I'm on a tablet and I'm on a computer.
Well,
I'm on a Chromebook.
Spark plug.
Is anyone else having this problem? Because it looks great on my end.
I can see it.
Okay,
The
so
wire is not the right.
huh?
I said I could see the wires, but I couldn't make out the writing. But I see it's spark plug wires.
Dang. Yep, spark plug wires.
Yeah, it doesn't show up too well.
Yep. No.
Huh. Wow, it's showing up great on mine, but
Yeah, that's great.
I'm not stealing internet from my neighbor, so maybe that's it.
Neither am I.
All right.
Hey,
I'm
my
on
phone's gonna die.
Spectrum
My
5G
computer
out
kicked me
here.
off because it was an update. Then I went on my phone, now my phone's gonna die. So I'm gonna go back to my computer and I'll be right back, okay?
All right.
Okay.
See, guys, you got to be prepared for this class.
Plug in your
I
stuff.
was doing an update.
Plug in your stuff. All right. So inside here, I have this big old can right here. And it's going to have one of these things, and it's going to have one of those things. It's going to have one of
Old school coil.
Oh, yeah.
Yep,
Ignition coil.
that's right. So that's going to be the positive side, and that's going to be the negative side. That's going to be the ignition coil, which remember is just a transformer. So it's going to have two windings. It's going to have this one with a bunch of windings. And it's going to have this one, with a few windings. See, it's a regular transformer, but what it is it has the secondary inside the primary. So sometimes people get confused on that.
I'm sorry, what was this called again? That piece?
Ignition
drawing?
coil. Oh, ignition
That's-
coil.
Ignition coil, okay.
Yeah.
Okay.
I'll see if I have one around the house and I'll drop it off at your
Well, we're done with this.
house, Ro.
No, we're done with this today. Thanks, though.
Yeah, but to have one if this happens again.
Nah, I got them at school. I'll be better prepared. Sorry about that. Okay, so this goes to the plus. And that's going to supply 12 volts to the ignition coil. Now, Chuck says, don't forget to bring this little wire from here out the top of the coil to the center right there. See that?
That's the coil wire.
That is the coil. Oh, shoot. I didn't mean to put it there. Doggone it. Shoot. Whatever. That's a coil wire. I may have just wrecked my drawing. Shoot. Anyways, we'll see. That's a coil wire.
Just make the PWM a little smaller.
Yeah. Yeah. Shoot.
Okay, what was the mistake? Where should it have gone then?
Just move this up more. Yeah, move this up as close to the distributor cap as you can. Sorry.
I
Yeah. Okay, so the purpose of the coil wire is to take the spark out of the transformer to the distributor cap, where it will travel to the rotor, which will then travel to each individual cylinder. Does that make sense?
Yep.
Yes.
Good. Okay.
And that rotor's arcing across to those poles, right?
Yep. Mhm. Yeah, which is what wears out the rotor. Yeah.
Right.
Yeah. That's why that's a regular maintenance item. Okay. Well, let me just do it this way because I've irked myself now. I'm going to go like this. That's a ground. And then I've got a switch that goes like this. I hate it when I irk myself, then I have to come back. That's a switch, yeah?
Mhm.
So where was my little drawing? This goes like this. And the little red thing goes like that too. You don't have to worry too much about that. They're common though. So basically what we're doing here is this is a ground side switch, yeah? Yeah.
Yes.
This is a ground side switch. So all we're doing is we're opening and closing that switch every time we want to send a spark down this wire. It's not actually a spark, it's a voltage, but it's going to be a spark. We are closing the switch every time we want the fields to build up. And we're opening the switch every time we want a big jolt of electricity to go down that coil wire and then go to each individual cylinder where it's going to turn into an arc at the spark plugs. I think this drawing's going to be okay. It's just not as good as it could be, but it's much easier on a 4x8 board, especially two of them. Anyways. So you can see that we got to open and close the switch every time we want a spark plug to fire, right? Which means we're going to have to do it a lot. Well, closing this switch is a big deal. And this is what was the probably the major maintenance item when it came to doing tune-ups back in the day.
Mm-hmm.
Because what we used to have to make that switch connection was called breaker points. And they were called breaker points because they would make and break the primary circuit. When the switch was closed, current would flow through the primary circuit, creating the magnetic field, inducing a field in the secondary. When the switch opened, primary field collapses, secondary field collapses. Big jolt of electricity goes through the coil wire to the spark plug, through the rotor and the cap. Yeah?
Mr. Roadcliffe, you remember the dwell meters?
Of course. Yeah.
Hey, someone came in the class, Roadcliffe.
Oh, yeah, shoot. I'm sorry. Oh, that was probably the text I got.
Show us.
There you are. How are you, kid? Oh, no. There you go. Good. Welcome back.
Thanks.
All right. Sorry about that. I got a text, but I just figured.
Okay.
Rudy called. Anyways, so good. Glad you're back. Isn't there some way you can change it to make it? Okay. Play, enter to exit, chime. Yeah, that's what I thought. Okay. Now it'll work. Woohoo! Only took me 4 weeks. So breaker points. Breaker points is a problem because breaker points is a mechanical switch. And what do you know about mechanical things? Mechanical things wear out.
They wear out. Like on a Volkswagen bug.
And not only that, but Chuck's brought up an important point. Because when these things wore out, not only did they didn't just go from good to bad, they went from good to worse to worse to worse to bad to horrible.
They're not working at all.
So let me show you how that worked. You got this?
Yeah.
Okay. Let's see how fast I can draw this. 2, 3, 4. And go like that. There's distributor cap. Distributor goes like this. It's got a distributor shaft. Comes down here like this.
It's got a little gear on it.
And it's going to have a little gear on the end. Goes like that. Call that a drive gear. Oh, this thing right here is called the distributor. And that thing right there is called the distributor cap. Hey, Jim, how is this drive gear driven? By what?
By another gear.
No, it's driven by the camshaft. There's a gear on the camshaft.
That's what I meant.
Oh, okay. All
I
right.
said it was another gear that went down into the engines.
The other gear. I was like, oh, that's correct. Okay.
Hey,
What? Go ahead.
no, I was just gonna say I shaved off one of those drive gears one time,
Yeah.
a long time ago.
On a Ford.
Yeah.
No, on a Plymouth Duster. I dropped a screw down into the distributor when I was putting the condenser in,
Yeah, that'll do it.
and didn't know it. Went to start the car. Yep.
See? That's why you Ivy Leaguers should stay away from screwdrivers. Is Duke Ivy League?
No.
Okay. Probably Tobacco League or something.
Yeah, tobacco leak. Yeah. Close to it.
Me and Jim are right there together.
Yeah.
Yeah.
Rudy went to the University of Highland Park.
You're hilarious.
All right. So inside the distributor, there's this thing called a rubbing block. And the rubbing block looks like this. And it's on the distributor shaft, so it spins as the camshaft spins. Rubbing block. And on this rubbing block, we have a switch. It's hard to draw. That's why I'm not going to spend too much time trying. But it looks like this. That's not terrible.
That's pretty good.
Yeah, that's good enough. That's called breaker points. That's the switch which is going to control the amount of current in the primary. And if we control the amount of current in the primary, we control the amount of energy in the secondary, right? Primary affects the secondary. No primary, no secondary. Okay, so what this is doing is it's controlling the path to ground to complete the circuit, because this is a ground side switch. Okay, so as long as these breaker points are closed, we'll have current flow. When they open up, no more current flow, field collapses. Can you see that as this rubbing block spins, this switch is going to open up and close like that?
Yep.
Yeah. This is not the spark plug gap. What is it, Rudy?
Points gap.
Point gap. Yep. And that had to be set with feeler gauges.
Mhm.
Now, what's important about the number of peaks, apexes, on this rubbing block?
Cylinders.
The more apexes, the more times the coil is going to open and close.
The number of apexes is going to determine how many times the field collapses. So Chuck's exactly right. It's matched to the number of cylinders in the car. Yeah, one revolution, and then we start all over again. Okay, but here's the problem. This is a mechanical device. Mechanical things wear.
Oh, was
What
it?
mechanical things wear?
Brakes.
All of them. Everything.
Sorry.
Yeah.
Everything.
Everything. Which is why, you know, back in the day when everything was mechanical, we used to have to work on cars all the time just to keep them running. I mean, people complain about how they got to get their car fixed these days, but it's nothing like the old days. I mean, you used to take your car, if you drove a lot, you'd have to take your car into a mechanic 2 or 3 times a year just to get the tune up, just to get the points adjusted.
Mm-hmm.
Yes.
Or more.
Point wear led to spark problems.
Kitty, stop it.
With duration and advance. Timing. Ignition timing refers to the relationship between piston location and spark plug firing. You like that, Chuck?
Yeah, looks good.
Piston ignition timing refers to where the piston is when the spark plug fires. I'll bet you couldn't find 3 people in Montclair that could give you that answer.
I bet you couldn't find 3 people in. No, you might be able to find 3 people in Los Angeles.
I can find 6 right here. Does that make sense? So one of the big problems we had with point gap is that as the breaker points wore, not only was there less time for the coil to charge, which is called coil saturation. Is Michelle still here, right? Michelle is still here.
Yeah, I'm here.
Because I keep getting these, I hope you realize I'm not answering my phone. Yeah, so
I don't know how I'm calling you.
the problem with spark duration is, if you don't have a whole lot of time to build up a strong spark, when it goes, it's not going to push out a very strong spark. That could be a problem. In fact, it often was. But the big problem was, as these breaker points wore, the spark would happen later and later, and it would for less time. And as a result, what would happen is your performance would just go down, 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 badly. So as your
Time would be off.
Yeah. Well, it would show up as your timing off, but your timing was set correctly. See, I figured out back in 81, probably 82. I figured out that as long as if I set my points correctly and then I set my timing correctly, I could just leave my timing exactly where it was, and I could adjust my points just by looking at the timing mark. But see, most people didn't do that because they didn't have dwell meters, Chuck, Raina.
I have one.
They didn't have dwell meters, but they had timing lights. So what they do is they would disregard the point wear, and they would just keep advancing the timing on the distributor, and pretty soon the car wouldn't run at all. And it wouldn't run good, because this is crucial. If you want a car with points to run good, this is the key right here. Really, that's the key to
Get rid of the points.
Yeah, that's what they did.
Go with a magnetic pickup.
You got this?
Yep.
Okay. Rudy's correct.
Go with a magnetic pickup.
For the first time in history, Rudy is correct about cars. Because what they did was they said, well, we can't be having these cars that have to be tuned up every 3 months. In 1969, we finally got rid of the Volkswagen Bug with the non-adjustable brakes. Now all brakes have self-adjusters, which means we don't have to go in every 3 months to get our brakes adjusted. You realize that back in the Model A days, you had to adjust your brakes all the time, or the pedal would just go to the floor as the linings wore out. Yeah. Okay, so electronic ignition. This is the second ignition system. Electronic ignition. Hey, Rudy, you remember the old King Taco days? Man, that was a long time ago, brother.
I remember the entry days.
What? I screwed up this drawing because I was thinking about King Taco. All right.
Pantry.
Oh man, I got to get to the pantry, man. This is bad. Go eat my 3 mouthfuls and done.
I thought the pantry closed down.
What?
Nope.
The one downtown?
Nope. It's closed for takeout only, but it's not shut down.
Oh, I heard it closed down permanently.
No.
Look like that.
Okay.
The old mayor wouldn't allow that.
Reorden?
Okay.
Yeah.
Hey, Rudy, is Felipe still open?
Yes, sir.
Oh, man. Those are the best sandwiches around.
Come on down. Come on down. We'll go get a Felipe sandwich.
Is that roast beef, right?
Yeah.
Or pork or lamb.
Are you sure it's open? I thought I heard that they closed. No?
Okay.
Well, okay. It might be closed for virus.
No,
It's not.
I
It's okay.
thought I
Stop.
said it was going to close permanently, but okay, I could be wrong.
First of all, way better roast beef sandwiches Antonio's on 3rd Street in Pomona. But we're running out of time, so we got to haul. Okay, look.
Okay.
Now we got a trigger wheel. What replaced the rubbing block is a trigger wheel. And this is the pickup coil. Now, does that make sense? So they replace the rubbing block with this, and they just put a pickup coil in here. So they're going to get an AC signal out, yeah?
Uh-huh.
AC signal looks like this.
Right. Wave up and down.
Yeah, but the problem is, when you're going at slow speeds, like I said before, the speed of the cutting action is going to determine the amplitude of the signal. When you're going at slow speeds, you're going to get a very slow signal out of this, and the coil is not going to like that. The coil does not want this kind of signal. This signal is called an analog signal.
Yeah.
Analog meaning it's got one value here, 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 one value here. It's got a million different values. Well, a ignition coil doesn't want an analog signal. It wants a digital signal, which is 1, 0, up, down, on, off. Like a switch, right? On, off, on, off, on, off.
It's binary.
Yeah. What? Dang, what's up, girl? That's correct. So what we had to do is we had to come in here and put it into an ignition module. Chuck, I'm about to make your life easy, but like 20 years too late. Okay, so ignition modules amplify and refine, pick up, coil, output. What does amplify mean?
Increase.
Makes it stronger.
Make it stronger, yeah. And when we refine it, we mean that we're going from an analog signal, which is what the rotating magnet creates,
Mm-hmm.
and we create a digital signal,
Digital signal.
which is what the coil wants. Now, what are the advantages of this system? Well, it's not a mechanical system, so it doesn't wear out. That's cool.
Well, it does, but it takes a whole lot longer to wear out.
Well, the distributor shaft bearings might wear out, but you know, these two aren't touching now.
But the pickup coils at the beginning started to wear out.
Well, not really wear out mechanically. I mean, they go bad, yeah. Okay. So the good thing about this was it made these way, way, way more reliable, and you didn't have to tune them up all the time. Early systems sucked. Later systems are much better, of course, but
This was before they went to cam and crankshaft position sensor.
oh yeah, way before.
They did the same thing.
Yeah. Although they still ran distributors till like what, 2005 or something? Way late.
Yeah.
Hondas and stuff? Yeah, they were way late. Okay, so this was system number 2, and it directly replaced the points. And it worked great for a long time. You know, they were using this system, like I said, from probably 75 to 2005. And they weren't having problems with, you know, having to freaking, all this service is a big problem, yeah? And you can't be having this car having to go into service all the time. But that was okay. But it wasn't great because the distributor shaft that this is mounted on is still kind of sloppy and it still flops around. And we still have, you know, some significant issues with not being able to control things as well as we want to. So you got this?
Yeah.
Okay. I did a video on this. In fact, I did a video on this. So I'm going to have sensors up here. And I'm going to have a whole bunch of sensors, right? And I'm going to have a PCM right here. And I'm going to have coil 1, coil 2, coil 3.
V6.
Hey, what are you doing?
That's V6. Now, primary sensors on this one are going to be like the CMP and the CKP, the crankshaft position sensor and the camshaft position sensor, because they're going to tell the computer exactly where the engine is in all of these 4-stroke cycles. And then it's going to send out this one to cylinder 1. Well, 1 and 1, 5, 4, 3. I'm going to send it out to 2 cylinders, actually. Each coil is feeding 2 cylinders, so Rudy's exactly correct. Now, why? Because we were not sophisticated and we didn't have powerful enough computers to control each one of these cylinders by themselves. So we just did 2 at a time, fired it twice as often. This right here is called a waste spark or distributorless ignition. So now we're taking the mechanical part out entirely.
As in the Ford Explorers.
We're not going to have a distributor anymore. We're just going to run crankshaft position sensor, camshaft position sensor to tell us when the spark plugs should fire. Then the PCM is going to take all this sensor input and it's going to determine spark advance. It's going to determine ignition timing. It's going to determine spark duration and a billion other things. And then it's going to tell the coils what it wants to do. So this was a huge advance. Because now instead of having 1 coil, remember back for the last 2 ignition systems, we've only had 1 coil for all the cylinders. Problem is that doesn't give you very much time to build up that coil impulse. As a result, the sparks were weak and they kept getting weaker the faster you ran the engine. So what we did here is instead of 1 coil, now we got 3 coils. So each coil is doing 1/3 of the work, which means now it's putting out way more power. These things would put out 80,000 volts.
Wow.
Yeah, which means you don't want to disconnect that spark plug wire with your bare hands.
Yeah.
Those would throw a spark like 1 inch long. It was awesome. And you know, it would fire those spark plugs guaranteed. Because one of the reasons we went to electronic ignition, and one of the reasons especially that we went to distributorless ignition, is that we kept moving the spark plug gap wider and wider. You know, this thing right here. Now, back in the old cars, that was 35 thousandths of an inch. Then it went to 45 thousandths. Then it went to 60 thousandths. Then it went to 80 thousandths. And on some cars, it even went to 100 thousandths of an inch. Well, we know that if we want to shoot a garden hose across a street, we got to have a lot of pressure. If we make the street wider, we got to have more pressure. So what we see is as the spark plug gap keeps getting bigger and bigger, we need to have more and more voltage to jump the gap. Besides, what we were finding out on the 2 early systems was that as the plugs got older and the resistance increased, all of a sudden these things wouldn't fire anymore. That was a big problem. Now, we went all the way up here on our spark plug gaps because we thought that having a bigger gap would give us a bigger spark and more complete combustion. Turned out it didn't work that way. So pretty much everyone these days is using about 45,000.
Yeah.
What is that, 1.1 millimeters?
Bless you.
That's coronavirus. Now, should I call it should I tell you why it's called the weight spark system?
Yeah.
Okay, it's called the weight spark system because they're going to fire 2 cylinders at a time. Now, they're called companion cylinders. That means they're both up like here, except one of them is just about to start the power stroke and the other one's just about to start the intake stroke. Yeah. This one's coming up on the compression stroke. This one's coming up on the exhaust stroke. Yeah. And then this one's going down on the power stroke while this one's going down on the intake stroke. That's harder to figure out than you know. Okay, but here's the thing. Let me ask you a question. So what happens as this piston comes up on the compression stroke as it gets close to top dead center?
The fuel and air mixture gets hot.
It's compressed, yeah.
Well, yeah, but the spark plug fires, right?
Yeah.
Okay. But let's look at this one. Piston's coming up on the exhaust stroke, blowing the smoke out. Now, what happens if I fire the spark plug during the exhaust stroke?
Nothing.
Nothing. I mean, it might light off some residual hydrocarbons, but basically nothing. So what they did, because we didn't have sufficient electronic sophistication to fire each cylinder by itself, they just fired each spark plug twice at the same time in the cycle. You know, whenever the piston was coming up on the compression stroke, they fired the spark plug. While the other piston was coming up on the exhaust stroke, they fired the spark plug. And what it did was it made it so while we were waiting to get sophisticated enough computers to control each cylinder by itself, it bought us some time. Just like, I might add, just like throttle body injection bought us some time before we had the electronic sophistication to control each injector for each cylinder. Does that make sense?
Mm-hmm.
Sequential injection.
Yeah. Throttle body injection means you're only controlling 1 injector instead of 8.
Or 2.
Yeah, much easier for the computer to do. But do you think it's going to work as good? Nah.
No.
Nah, it's not. And this system had its problems too. But it was the best we could do at the time. Let me ask you a question. If one of these coils go bad, how many cylinders go bad?
2.
2. Yeah. Yeah, we learned that the hard way, right, Chuck?
Yeah.
Okay, so that's called distributorless ignition. Lots of cars had it. It went on for what, early 90s
to early 2000s.
Yeah, probably so. Yeah. Mm-hmm.
They don't use that kind at all anymore?
No, I don't think so. I think everyone's on Coil Unplugged now, aren't they?
Okay.
Yeah.
Yeah, I am.
Yeah, I believe so.
Because now we have the computer sophistication to do the right thing, which is port fuel injection, direct fuel injection, and Coil Unplugged.
What do you think's better out of those 3?
The new stuff's all, well,
Direct
injection and port injection are working together, and Coil Unplug is an ignition system, so they're all working together, right? That's the state of the art in ignition and fuel systems today. Okay, so we got, that's distributorless ignition. Can I turn?
Mm-hmm.
Yeah.
Yeah, okay. Now, I did a pretty good video on computerized engine controls that's on my channel, same channel. that will help you through that, because I forget the question we were asking. What determines spark advance, or what affects spark advance, or something?
Well,
I think, yeah, or something. I can't remember, but you'll see. You'll see back when there was 30% more of me. That was a joke. So finally we get to coil on plug, because least reliable parts on an engine were and are, if you still got them, what? Spark plug wires.
Oh.
Absolutely unreliable. Super delicate, super finicky. They got all kinds of voltage, so they're always looking for some place to arc to.
Stop.
So.
And if you had some dumb mechanic put them in, they might lay them on the header.
They always did. Always did. And if you bought cheap headers, there'd be no way to keep them off the header. Yeah. Always did. In fact, you know, they did that with a Suburban. It's the way these people are. So, coil on plug came about because we had to get rid of spark plug wires. The spark plug wires were causing 90% of the failures in our ignition systems and about 50% of the failures in our engines. It's just unacceptable. So what we did now was we're going to have the little sparkalito. How do you say sparkalito in Spanish? That would be the chispador. Bujia.
Bujia.
Yep. There's a little sparkalito.
Stop it. Booger, come on now. Stop. Stop.
Let me see her.
This goes like that.
Yeah.
And then that goes the coil. There we go. Coil on plug looks like that. So now, let me ask you a question. So now each spark plug has its own coil.
Booger, can you stop?
That's an expensive way to do it. But, you know, it's the best way to do it.
It's reliable.
It's super reliable, and it's super powerful. It puts all kinds of juice down that spark plug, which is good because that means it'll run 100,000 miles, 120,000 miles without even changing the spark plug.
Very low maintenance.
Yeah, extraordinarily low maintenance. Yeah. And if one of these coils fails, what's going to happen?
You only have a misfire on one cylinder.
Yeah.
Yeah, it's true. You're going to have a misfire on one cylinder, but what's going to happen on your dashboard?
You're going to get a check engine light.
You're going to get a check engine light right away. Yeah, it's cool. Very cool. Now, my question to you is, the wires that are going to this coil now, are they secondary wires or primary wires?
Secondary.
Ooh.
They're just 12 volts going into it.
It's 12 volts going into it, so they're primary wires, which means they aren't looking to arc any place, and they aren't really sensitive, and they don't have insulation breakdown and all that other crap. Yeah, it's just basically it's the same wire that goes to the fuel injector. Super reliable, lasts for hundreds of thousands of miles. So we got rid of the spark plug wire, which means we got rid of the spark plug wire's problem.
Damn.
On this ignition system, the secondary only goes from here to there. Which is why you got to make sure this part isn't wet with oil, because that's a conductor. Okay, so that's coil on plug. We've got one coil for each spark plug. Fires the spark plugs like crazy. Everybody's happy. Get it?
Mm-hmm.
Yep.
That's it. That's basically it, folks. Yeah, you're fine.
She's cute.
She wants to learn automotive. Who could blame her?
I do.
Quack.
Stop, girl. Sit down.
Eh.
Sleepy.
How old is she?
Huh?
How old is she?
Oh, she won.
Wow, congratulations, man. That's cool.
Yeah.
Good for
Yeah,
you.
I'm sending her to Montclair High School.
Oh no. Well, maybe she'll get there in time for me or not. You never know. If I still have a job by then, yeah. Have been replaced by Electude, the friendly robot.
Yeah.
Who knows?
Yep, who knows?
So that's Coil Unplugged. Billion times better. And what it means is that we can control each cylinder individually, actually, which is kind of groovy if you think about it. So, questions, comments, thoughts on that?
Not right now. I'm gonna have some look.
Okay. Ignition timing. Ignition timing refers to relationships. We're always talking about relationships. Relationship between piston location. Oh, is that the tip bell? Between piston location and spark plug fire.
Ignition.
Yeah.
Somebody's got feedback.
It's an airplane.
Is that it, or is it an airplane?
Yeah, it's
Stop
airplane.
it.
Usually, well, almost always, timing is BTDC.
Before top dead center.
Top dead center. Yeah, it's always going to be before top dead center. Let's put it that way. But, you know, I've been wrong before. Why? Because it takes time. Combustion takes time. And what we need to do is we need to have maximum cylinder pressure at minimum cylinder volume. Why? What is that? P equals F times A or something? Pressure equals force times area?
Something like that.
No, P equals F over A. So the smaller the A is, the greater the force is. Yeah, okay. So what happens is we need to have maximum combustion when the piston's right at the top. Let me do it like this. Here's the combustion chamber like this. Here's the piston coming up. Can you see how the volume of the cylinder is at its minimum right there? And as the piston goes down, the volume increases. We need to have maximum cylinder pressure when the piston's at the top, which means we have to start it burning before the piston gets there. That makes sense?
Yeah.
This combustion takes time. What is it, 25,000 feet per second or something? I should quit quoting this stuff out of my head now that it's recorded. Everyone be screaming in the comments about my misremembering. Oh, another tip. Hooray! I'm going to be rich. Yeah.
Stop it.
My parents raised me to be a cam boy. Well, they took me to Cambodia when I was young.
Jeez.
Holiday in Cambodia.
Yep. There you go. All right, so that's what timing is. Timing refers to the relationship between the piston location and the spark plug firing. You got that?
Got it.
Yep.
Okay. Almost done.
Yay, we're running over tonight.
Well, I just, I want to finish the lesson, right? Advance.
But you gotta stop. I'm trying to work.
Yeah, especially since you showed up late, Kaufman. Advance is necessary.
Really? I rated the latest one to show up.
No, but you're just a bad example. Advance is necessary as engine RPM increases. I'm rich.
That's what she's supposed to be looking at. This. Why she stop? You trying to grab everything, but what?
That's a cute kid, dude.
That's her mom left and went to the store, and now I'm stuck. Stop it.
It won't be long. Okay, spark advance. Well, I guess I should say that. Spark advance. Spark advance is necessary as engine RPM increases
Spark advance.
because we will have less time for combustion because everything's happening quicker. We'll have less time for combustion. So we need to start
Firing it earlier.
Yep.
That's because
we have less time for combustion, so we need to start earlier. Let me ask you a question. If someone's pitching to me at 50 miles an hour, I can start my swing at a certain point, right? But if they're pitching to me at 100 miles an hour, don't I have to start swinging sooner?
Yep.
Yes.
Same reason. Because the ball is going to be over the plate for a much shorter amount of time, so I have to make sure that the bat is there when the ball gets there. So spark advance refers to increasingly firing the spark plug sooner and sooner as engine speed goes up. Now, that's not the only reason we would have spark advance, but that's the primary one. Hey, Chuck, if I have not enough advance, what's my symptom going to be?
The motor be labored. Won't have no pep.
Low power. Yep. If I have too much advance,
Pre-detonation.
it won't be pre-ignition.
Yeah.
Because pre-ignition is what, Rudy?
The fuel and air mixture firing before the spark plug fires.
Let's say, just say combust.
Okay.
There we go. Can you see that? Pre-ignition is when the air fuel mixture combusts before the spark plug fires. What makes it pre-ignite?
What? What makes it what?
What causes pre-ignition?
Heat? Too much heat?
Too much heat. Primarily too much heat. Could be mixture issues, but rarely. And very commonly, it's glowing carbon deposits on top of the piston, which is why you got to make sure you get those. Hey, Chuck, how do you get those deposits off the top of your pistons?
I use Marvel Mystery Oil.
Oh, that's right, huh?
Or fuel system cleaner.
Or you could be like me and just spray a bottle of water into the intake. Marble mixture is probably better though. Okay, too much advance causes detonation, which is terrible, very bad.
This is impossible. Booga, if you don't stop. Okay, chill out. Come on.
Well, whatever you don't get, it'll be on the tape. It'll be on YouTube, you know, in a couple hours anyway. But yeah, it's good to
She's
see
actually
you.
being pretty good.
Yeah, huh?
If you call this good, okay.
Yeah.
Good. That's good. Better than my. Not quite. All right. So here's the thing. How do I know if I got too much spark advance?
Because they'll be detonating.
Causes what?
Knocking or something.
It'll be knocking. That's true. But before I even get there, hopefully I've got a knock sensor.
Check engine light with knock sensors.
Yep.
No.
That's what started my project. Really, was the knock sensor.
Oh yeah, if it's completely bad.
Yeah.
Well, but the knock sensor is supposed to report to the PCM.
Stop.
To get the PCM to do what?
To retard
Hard
the
to timing.
timing.
Good.
Yeah.
Yep. And the PCM is going to be doing that all the time. Hopefully, well, actually, hopefully not ever, but it's going to be ready to. You can look on your scan tool and see if it's operating. All right, what are we doing next week?
Working on your Suburban.
Besides taking
I
out,
like diagnosing and stuff.
Suburban is nice now. Suburban is groovy.
We
Um,
start the timing.
What are you getting, a haircut? Illegal haircut? I'm going to report it to Gavin Newsom. I'm going to report it to Gavin Newsom because I'm a freaking snitch and I can't stand it.
Yeah.
That's it. Karen Rocliffe, that's on me. Yep. Yep. Judge, you see they were talking about, separating families. If you tested positive for COVID, they were going to take you away from your family.
I'd like to see him try.
Ventura County. Yeah. Nice.
Yeah.
Nice.
Scary. Very scary.
Crazy. How can you do that?
Oh, they're telling people they can't work, so what's next?
I don't
right.
know. I'm still working.
That's good. Keep it that way, man. Keep it that way.
For real, 'cause it's going to be hard later on.
Yeah. Yeah. All right. Questions, comments, thoughts on ignition systems? I don't know that I have too much more on ignition systems to do. What else we got?
All kind of stuff to do.
We could do history of emission systems, or we could do something like boring and mundane, like steering and suspension or brakes or something. Well, we already
What did you pick?
did. Yeah, we already did. So yeah, let's do that. Anna Maria, did you learn anything?
Today, you mean? Yes, I did.
Cool. Good. Good. Okay, and you guys haven't heard anything from Chafee Adult School yet, huh?
No, I haven't received.
They got my wrong email, so I'm not going to hear nothing from them.
I'll go by there Monday or I'll call him. You haven't heard anything either?
Yeah, well,
I
I
haven't.
haven't received any emails, so.
here's what you have to
I
understand.
don't get emails.
Well,
Let me know if y'all receive them, because I don't get them.
here's the thing. Every school listens more to the clients than they do to the servants.
True.
Yeah, so we can say stuff all day long, but until you guys start complaining or making observations or whatever you call it, that's what'll cause the change, because we need to make sure that adult school stays open.
Okay, I'll do what I can.
Yeah. So I mean, the way we do that is by being here and participating, right?
Yeah.
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 Okay.
Yeah, I'll send Todd an email. Not a problem.
Oh, damn. I didn't know you were on first name basis.
Tearing up my couch. God dang
Did
it.
you get a hold of any of the other students? There's no way to get a hold of them?
I got the wrong.
Kind of late now, huh?
I got the wrong numbers and addresses for them.
Open your mouth.
Bummer.
So, all right, folks. I sure appreciate it. Have a great weekend, and I'll see
Okay.
you next week.
See you next week.
Thanks so
Stay.
much.
Good night.
Oh, see y'all later.
Bye-bye.
Bye-bye.
Appreciate it. Thanks for coming
Bye-bye.
by.
Bye. Son.
Bye.
Bye-bye.
Bye.
Yeah.
I'm ready.